Hello. So if you guys haven't already seen the 3blue1brown video where he talks about topology and Möbius strips, I have that linked below. Definitely watch that first because he uses graphics to visualize this, and as you can see, my supplies here are not so great. But basically what we have is the line XX is graphed here. And what we want to do is take this Cartesian plane and morph it into a Möbius strip such that the edge of the Möbius strip is the line XX with points meeting at infinity. In the 3blue1brown video, he just uses this positive region, but in what I'm going to be trying to do is use the full plane and also something else, which we'll get to a little bit later. But right now I'm basically copying his technique, which is to fold over the line XX. Okay? So now we have all of our points that are to the left and above XX, and to the right and below XX are the same. They've all matched up. And then the next step, you'll see, is one of the sides is flipped and then is reconnected over here. And now we're ready to make a strip. But you can see, I don't know if you guys can actually see, but right here we have the positive part of the x-axis. Right here we have the negative part of the x-axis. If we flip it over, we have here the positive part of the y-axis and the negative part of the y-axis. And the sides, which are going to become one side, is the line xx. You can see here this line drawn on here. Okay? Now, I can show you guys right now. Obviously it's hard to make this into a strip because it's a square, but I just stretched it and made it here on a strip. Let's see if this fits on the camera so we can forget about this. This is the same exactly. We have the positive part of the y-axis. This is a point at infinity. This is the negative part of the y-axis. And then here we have positive part of the x and negative part of the x. The sides are the line xx. Oh, and this is point at infinity here. Okay. So now I have also the line x negative x graphed here. And we're going to do the same thing. Fold over that line x negative x. So now the points to the top and right of it and bottom left of it are the same. We do this same move here where we flip one, we reconnect like this, and now we have the negative the negative part of the y-axis here, the positive part of the y-axis here, and if we flip, we have the negative part of the x-axis here and the positive part of the x-axis over here. Okay? And this is what it looks like on a strip. You can forget about these squares now. Same exact thing as before, it's just changed from a square into a rectangle, so we'll be able to make it into a band easier. Negative part of the x-axis, I don't know if this is redundant now to go through, points at infinity. Positive part of the x-axis on the bottom, flip it over. Positive part of the y-axis, infinity. And the negative part of the y-axis. And the sides, which are going to be one side, is the line x negative x. Okay? So now we have our two unfolded Möbius bands. Here, let's arrange them like this so it's easier. So you can see already we're going to have a problem here because this is actually, they're identical here as far as the y-axis is concerned. This is the positive part of the y-axis. and this is the negative part of the y-axis. Now, what should be noted here is that these numbers are actually getting bigger, and these are getting bigger as well, because this is this point here is infinite. It's an infinitely big and infinitely small number that's being met right here. It's not like your normal y-axis. I know it's arranged positive and negative, but it's actually, this is, you saw it was a torn piece of paper, so this is 0 and this is 0 at either point. Okay, now let's try to make some Möbius bands. Oh, sorry, this is what I was going to show you. On this side, they're not identical, because this is negative on the line x negative x. This is the negative part of the x-axis, whereas this is the positive part of the x-axis for the band which has the edges as xx. Okay, this is getting a little confusing. The point is they're not identical, obviously, because they're taken from different lines. Now, we can take them both and make them into some bands. Okay. And what I should have said much earlier in the video, what I'm trying to do is create a shape to replace the Cartesian plane, and to connect these such that the x and y axes line up with one another. And we can actually do that for part of it. This is where it gets really tough to show you guys. But you see right here, I have written negative y, and on this one as well, negative y. And if you remember, the negative y connects to the positive y. So I could have this one, intersect through here, and then along this axis they would be shared. So this Möbius band that I'm shaking right now would intersect through this one along this shared line, and this would work all the way around until we get back to the other side, in which we'll see in here that's where positive y ends up being, just on the other side of, well, it's actually the same side, but you know what I mean, the other side of right here. And on this one it's the same. You see that positive y in there. But the issue is that we've actually already messed up, because as far as the other side is concerned, we have on this one it's the positive x that's in here, and on this one it's the negative x that's in here. And I'm sorry this is so sloppy and you can't even really see what I'm doing, but hopefully it was a clear enough video that you understand the problem, and maybe some of you have a solution. I don't know if this has to go into another dimension for this to work, or we just have to do something funky with intersections and breaking these apart, and something that's very difficult to do with paper. But yeah, this is how far I've gotten with this problem, and maybe you guys have some ideas as well. Okay, thank you.